Now that we've worked with positive rational exponents, we've got to work with negative rational exponents. And really, there's not a whole lot of difference between positive and negative. Just one extra step. So with a negative rational exponent, we know with negative exponents, we actually flip our whatever it's going to. So as an example, let's say that I have 125 to the power of negative 1/3. Okay, so there are a couple different ways that you can do this. I'm just going to show you one way. I think it'll just be uniform that way if we all do it the same. So the first thing I'm going to do is I'm going to break down this fraction. I'm going to break it down into 125 to the negative 1 and then to the power of 1/3. Okay, I think this is a little bit easier. We take care of the negative right away and then we deal with the fraction exponent just like we've always done. So inside my first parentheses, 125 to the power of negative 1 is now going to be 1 over 125. This is now to the power of 1/3. So that right there, when we use that negative 1 and we flip it, that's our negative exponent theorem. Okay? Now the 1/3 is on the outside as a power. So that 1/3, when we have our quotient, goes to the 1 as well as the 125. So when we're looking at this, I now have 1 to the power of 1/3 divided by 125 to the power of 1/3. Well, 1 to the power of 1/3 is just 1. 125 to the power of 1/3 is 5. So our answer then is just 1/5. All right, so it doesn't always work out that easily that we are dealing with a 1 over. So let's say, though, that I have 32 over 243, and that's to the power of negative 2/5. Okay, so I'm going to break this down. I'm going to have 32 to the power of 243, to the power of negative 1, to the power of 2/5. Okay, this way I'm taking care of the negative right away, and then everything else is what we've done so far. So I flip my fraction. It's now 243 over 32 to the power of 2/5. Now remember, when we're dealing with a fraction like this, because I don't have that 1 on top, I'm actually going to break this down. I'm going to break it down into the power of 243 divided by 32 to the power of 1/5 to the power of 2. So technically you could combine these two steps together in order to break it down a little bit. All right, so 243 to the power of 1/5 gives me 3. 32 to the power of 1/5 gives me 2. So now I've got 3 over 2 squared. Now the 2 goes to both the 3 and the 2. 3 squared gives me 9. 2 squared gives me 4. So my final answer is 9 over 4. So compared to the last example, I just have another breakdown within my exponents just because it's a different fraction, not a 1 over something. I got to break it down with the break down the 2/5 into 1/5 and then 2. Last but not least, if I'm actually solving for a variable, so the first two examples were just simplifying. Let's say I have x to the power of negative 3/5 equals 1 over 8. All right, so same rule applies here. In order for me to get rid of that exponent, I need to multiply it or take it to the power of negative 5 over 3. When I take it to the power of negative 5 over 3, this exponent on the left side, they cancel, because we would have negative 1 times negative 1, or negative 1 over negative 1 to give me positive 1. So I now have x to the power of 1/8 to the power of negative 1 to the power of 1/3 to the power of 5. If you really wanted to break it down that far, you could. So now I've got x equals 8 over 1 to the power of 1/3 to the power of 5. Notice, even though I broke it down into negative 1, 1/3, and 5, I'm still going step by step on the outside of my parentheses there. So now I have 8 to the power of 1/3 gives me 2, and now I got to take that to the power of 5. 2 to the power of 5 gives me 32. So it is similar to positive exponents, it's just we add in an extra step with that negative, in that we need to flip our fraction or to make it into a fraction in order to then go throughout with the 1/3 and the 5, or whatever your problem may be.